Intro to coin swaps. In this video, I will discuss what Bitcoin swaps are and how Bitcoin software projects use them. Swaps are a popular topic in the Bitcoin space right now because they are a cool thing you can do with Bitcoin, and several applications have come out recently that use swaps. Some programs that use swaps right now include merchant software, messaging apps, art programs, and Bitcoin exchanges where no one needs to create an account or give up their personal info. There are also promising developments on the horizon that use Bitcoin's swap technology, including privacy software, discrete log contracts, file storage, issued assets, and smart contracts. It's a lot of stuff, so let's get into it. There are three major kinds of swaps in Bitcoin: layer swaps, coin swaps, and data swaps. In a layer swap, you trade Bitcoins in a regular Bitcoin address for Bitcoins on the Lightning Network, or vice versa. In a coin swap, you trade Bitcoins in one address for Bitcoins in another address, without revealing the whole transaction on the blockchain. Coin swaps are the focus of Bitcoin privacy software. Data swaps trade Bitcoins for data, including messages, files, contract assurances, and other digital assets. Technically, all Bitcoin swaps are data swaps, because Bitcoins themselves are just a type of data. Bitcoins are a number associated with a Bitcoin address, and Bitcoin addresses are also just a number. When you do a layer swap or a coin swap, you're ultimately receiving other Bitcoins, but that's still a form of data, which means you're still doing a data swap. Layer swaps. Layer swaps are the most basic kind of swap. A layer swap trades Bitcoins in a regular Bitcoin address for Bitcoins on the Lightning Network, or vice versa. They are sometimes called submarine swaps because, like a submarine, they go between a higher layer, the Lightning Network, and a lower layer, the base layer, where normal Bitcoin addresses are. Layer swaps are easy to do and are built into several Lightning wallets, including Electrum, Phoenix Wallet, and Breez Wallet. Suppose that a month ago you put some Bitcoins in a Lightning channel, but now you've spent them all and your channel is empty. You could send some additional money to your wallet and open up a new Lightning channel. Or you can use a layer swap to refill the channel you already have. That's how Breez Wallet does it. Breez gives you an address which, when you send money to it, that money automatically gets deposited into your Lightning channel using a layer swap. At a technical level, layer swaps work like this. When you want to do a layer swap, your wallet provider sends a message to your Bitcoin wallet asking it to create something called a hashlock. A hashlock is similar to a password. It guards a Bitcoin address so that the money inside can only be spent by someone who knows some secret data. Your Bitcoin wallet generates this secret data in the background and then works with your wallet provider to create a Bitcoin address guarded by that hashlock, as well as by the private key of your wallet provider. That way, your wallet provider can spend the money in that address, but only if they get the password that you control. Your next step is to send money to that address. You can still recover this money, because there's also a time lock on the address that says you can recover it after 24 hours if your wallet provider doesn't move it. But you don't want to wait 24 hours, so instead, your wallet creates a Lightning invoice using the same password that guards your hashlocked address. Your wallet provider sends you money using that Lightning invoice, and your wallet can only accept it by revealing the password to your wallet provider. Once they have the password, they use it with their private key to move the money out of the Bitcoin address you created earlier. Voila! You've swapped coins from the base layer to the Lightning layer without ever giving up control of the money, and you've refilled your Lightning channel without needing to close it and open a new one. That's how a layer swap works. The same thing also works in reverse. If you're a merchant who accepts Bitcoins over the Lightning Network, you'll know that when your channels get full, it's hard to receive payments. Layer swaps allow you to empty your channels so that you can receive payments again while still retaining full control of your money. You just do the reverse of a regular layer swap. Your wallet asks a swap provider to create a hashlock, and then your wallet works with that swap provider to generate an address guarded by your private key and that hashlock. Your swap provider sends money to the Bitcoin address and then generates a Lightning invoice which you pay. He can only accept that payment if he provides your wallet with the password that protects the Bitcoin address, and then your wallet uses that password, plus your private keys, to move the money out of the Bitcoin address and into your wallet. Using layer swaps, you can easily move Bitcoins from the Lightning layer to the base layer, or vice versa, without ever giving up control of your money. The critical part of layer swaps, and really of all Bitcoin swaps, is the hashlock. Hashlocks allow you to put money in an address that someone else has the private keys to, but they still can't move that money, even with the private keys, until they learn the password. This is what turns all other types of Bitcoin swaps into data swaps. Ultimately, you're adding value to a password by making it the only way someone can access some money, and then you're selling that password for Bitcoins, either on the Lightning Network or in the base layer. Hashlocks enable all sorts of incredible programming tricks that add value to the Bitcoin network by giving users the ability to exchange data for money with very strong cryptographic guarantees. Coin swaps. Coin swaps are a promising privacy enhancement that use swap technology to hide the receiving address in a Bitcoin transaction. A coin swap looks like a regular Bitcoin transaction where coins go from one address to another. But in fact, the coins go to a completely unconnected address, and you can't find out which one just by looking at data on the blockchain. If that sounds impossible, let's use layer swaps as an example because they're very similar to coin swaps. If you use a Lightning wallet that supports layer swaps, can someone figure out who ultimately received the money just by looking at the transaction on a blockchain explorer? No. They can see that you deposited money to a swap address, but that address might be yours or it might be the swap provider's, and that all depends on whether or not you give the password to the swap provider in exchange for a Lightning payment. That password is not something that goes on the blockchain. So if you're just looking at the blockchain, you don't know who owns that address. In fact, the payment ultimately went to your Lightning wallet, which means the money is now controlled by an address that had nothing to do with the payment transaction. The address of the recipient can't be discovered unless you know the password, which Lightning wallet generated that password, and what its Bitcoin address is. Coin swaps do the same thing, except without the Lightning Network. In a coin swap, your wallet generates a Bitcoin address with someone, just like how it did in a layer swap. This Bitcoin address is protected by a hashlock as well as the other person's private key, and then your wallet sends some money to that address. Now, at the same time, both wallets, yours and the other person's, do several smaller transactions that are the reverse of the original. The other person sends some money into a few addresses which are under the control of your private key, as well as a password generated by the other person. You then swap the passwords, and the transfer is complete. You've swapped your coins for fresh coins from someone else, and all transactions look like a regular Bitcoin transaction from A to B. The fact that your Bitcoins are in fresh new addresses is invisible to anyone who doesn't know about the hashlocks. Also, no one can be cheated in a coin swap. If anybody backs out of the swap, there's a time lock that lets each person recover their money if it hasn't moved after a certain amount of time. Coin swaps are under development by the team behind joinmarket wallet. If you count layer swaps, which really are very similar, then there are already several wallets that offer coin swaps, namely Electrum, Phoenix, and Breez. But personally, joinmarket is one of my favorite wallets, so I'm really looking forward to what that team comes up with. Data swaps. Data swaps are exciting because, using them, you can exchange Bitcoins on the base layer or on the Lightning Network for messages, files, contract assurances, and other digital assets. As I mentioned before, technically all Bitcoin swaps are data swaps because you're ultimately just creating a valuable password and then selling that password for Bitcoins. What makes data swaps different is the thing that makes the password valuable. Instead of being anonymized Bitcoins, or Bitcoins on another layer, it's any other type of data, such as a message or a file. In a data swap, the password you need to move Bitcoins from the swap address is generated by hashing the data itself. And that means that in order for the other party to receive their money, they need to provide you with accurate data that matches the file you want. Data swaps are a very promising field of development in Bitcoin because almost anything can be done with them. For example, take a look at the private messaging app Juggernaut. You may not know this, but Juggernaut is built entirely on top of Bitcoin's Lightning Network, and it uses data swaps to transmit messages. Every message sent to someone using Juggernaut is encrypted using a key provided by the recipient's Bitcoin wallet, and then that encrypted data is entirely transmitted over the Lightning Network from the sender to the recipient by a bunch of hops where the data is swapped for Bitcoins. And since it's encrypted, only the sender and the recipient can read the message. I mean, that's an incredible use of swap technology, all enabled by Bitcoin. Another protocol doing something similar is sphinx.chat. They offer a very similar messaging experience as Juggernaut, but with one extra detail. In addition to sending messages, you can also upload encrypted files to their server, which the server only sees as an encrypted jumble of random numbers and letters. And then you can sell the decryption key to your files to other Sphinx users. That way, people can download your file from the server and decrypt it without anyone else knowing what they downloaded. Sphinx can also make some money by providing anonymous file storage and data delivery. A startup called Shirred Bits is using data swaps to create a type of smart contract called a discrete log contract. These smart contracts allow you to create contracts to pay someone or get paid, depending on what a third party says. The example they often give is a futures contract. Suppose you make a contract with someone that if the price of Bitcoin rises by $100 over the next year, they pay you $10. Otherwise, you pay them $10. This is a futures contract. You can then make your contract depend on data provided by Shirred Bits. If in a month they say the price of Bitcoin rose, you get your money, otherwise you pay out. You can put money in a swap address based on this contract, and after that your wallet will handle everything automatically, without Shirred Bits or anyone else ever having custody of your money. A company called Pandora Core is using data swaps to create other digital assets on top of Bitcoin's Lightning Network. These new digital assets will potentially allow people to create shareholder agreements and stablecoins that inherit the properties of Bitcoin's Lightning Network, such as instant transfers and enhanced privacy. Pandora Core says that this technology will enable accountless exchanges, digital identity, and many other developments. The field of swap technology in Bitcoin is only growing day by day, and if you're a developer, now is the time to jump in. Take a look at the resources in this video's description if you'd like to get involved and learn more. I personally am very excited about the prospect of all these developments built on top of Bitcoin's strong cryptographic guarantees. And in future videos, I look forward to demoing the software projects that I've highlighted in this video and explaining how they work in greater detail. So stay tuned.